Hi, I'm George Woodbury from College of the Sequoias in Visalia, California. And in this video, this will be part 3 of a 5-part final exam review for my Intermediate Algebra class. In this video, we'll take a look at problems that come from Chapter 11. This deals with functions and their graphs. First problem, evaluate f of x equals 2x plus 21. We're going to look to find f of 2a plus 10. So when we evaluate a function, the value or expression inside the parentheses gets substituted for the variable in the problem. And then we either use order of operations or we simplify the algebraic expression. Here we'll distribute 2. 2 times 2a is 4a. 2 times 10 is 20. Plus the remaining 21. We'll combine like terms and we get 4a plus 41. In this problem, we look to graph this equation because it involves x squared as its largest term. We know the graph will be a parabola. To find the parabola, we'll begin by looking for the vertex, and because of the form that this is in, we'll use negative b over 2a to find the x coordinate of the vertex. So that's going to be negative 6 over 2 times 1, which is negative 3 for x. We'll substitute that in to find y. Y equals negative 3 squared plus 6 times negative 3 plus 10. Order of operations, we'll square that. Negative 3 squared is 9. 6 times negative 3 will be negative 18 plus 10. And 9 minus 18 plus 10 is equal to 1. So the vertex is at the point 3, 1. Next thing we'll look for is the y-intercept. The y-intercept is the point where x is equal to 0. Here that's going to be y equals 0 squared plus 6 times 0 plus 10, and that is simply equal to 10. So the y-intercept is at 0, 10. Now if we were to need the x-intercept, we would substitute 0 for y, but in this case that's not going to be necessary. If we think about this graph, the vertex is at 3, 1, and it opens upward from there. That means that this graph can never cross the x-axis. Therefore, there are no x-intercepts. By the way, the reason we know this parabola opens upward is because a is a positive 1. If a is positive, the graph opens upward. Negative, it opens downward. Okay, now we'll use GeoGebra to display the graph that we just found the points for. Recall the vertex was at negative 3, 1. Then we found that the y-intercept was at 0, 10. The axis of symmetry is the vertical axis at x equals negative 3. Now notice that my y-intercept is 3 units to the right of that axis, so I can plot another point that's 3 units to the left. And now my job is to draw the smooth curve U-shaped that goes through these 3 points, and here it is. Okay, on to graph another parabola. This one's in what we call HK form. First thing I notice, the negative sign tells me that this graph opens downward. And the vertex I read directly from the equation. The vertex is negative 3, 8. The negative 3 comes from the fact that it's x minus h. Inside the parentheses, this is equivalent to x minus, sorry about that. This is equivalent to x minus negative 3. So h is negative 3. K is the value that's added or subtracted onto the end. So the vertex is at negative 3, 8. In order to find the y-intercept, there's a little more work here than in the last problem. Substitute 0 for x. And we have to do a little arithmetic. 0 plus 3 is 3, and squared that's 9, so we have negative 9 plus 8 y is -1. So 0, -1 is the y-intercept. When we go looking for the x-intercept, or intercepts, we set y equal to 0. So 0 equals -x plus 3 squared plus 8. Let's move the squared term to the left so that it becomes positive. X plus 3 squared equals 8. Time to take the square root of both sides. Extracting square roots, we call that. Don't forget the plus or minus on the right hand side. Simplifying each square root, this becomes x plus 3 equals plus or minus 2 square root of 2. 8 is 4 times 2, and we know the square root of 4 is 2. Subtract over the 3. Okay, when we need approximate values here, -3 plus 2 square root 2 is approximately -0.2. The square root of 8 is approximately 2.8. Same for 2 times the square root of 2. So -3 plus 2.8 is approximately -0.2. -3 minus that value is -5.8. So we can find our x-intercepts at approximately -0.20 and -5.80. All right, now we'll use GeoGebra to graph this equation. We found that the vertex was -3, 8, so we'll put a point there. When we substituted 0 in for x, we found that the y-intercept was at -1, so we'll place a second point there. The axis of symmetry was at -3, x equals -3. The y-intercept is 3 units to the right of that, so we'll plot another mirror point 3 units to the left of that. And we found that the x-intercepts were approximately at -5.80 and -0.20. And we finished by drawing the equation. Notice that GeoGebra changed it to an equivalent format, but this was negative quantity x plus 3 quantity squared plus 8. And there's your graph. Moving on to the next graph, here we have an absolute value function. We're going to look for hk first. Here, h is going to be -3 and k is -4. Again, this is the same as x minus -3 and plus -4. So -3, -4 for hk. This absolute value function will move upwards, open upwards, because it's positive, not negative. -3, -4. That's where our graph will bottom out. It'll move up from there. I'll show you a more precise graph on the next screen. Okay, let's go ahead and create the graph. We know that the absolute value function, which opened upward, turned around at the point -3, -4. So I put a point there, and then I draw the V-shaped curve through it, keeping in mind that it follows a slope of +1 to the right and -1 on the left. Here's the V-shaped curve, and there's your graph. Now we have a square root function. hk here will be -1, -7. -1 causes the radicand to equal 0. -7 is the result at that point. Remember that an absolute value function starts at 0, 0 and moves in that fashion. Well, we're going to have the same graph, except it's going to start down here at -1, -7. On the next screen, I'll show you a more precise graph and how to come up with that. Okay, now we'll use GeoGebra to graph this function. We would start with the basic graph y equals square root of x. Starts at 0, 0, extends upward to the right, goes through the points 1, 1, 4, 2, and 9, 3, for example. Now we're going to shift this 1 unit to the left and 7 units downward to begin at the point -1, -7. We want the graph to go up and out from there. We could include points, translate 1, 1 to 0, to 0, -6, translate 4, 2 over to 3, -5. But here's the graph, starting at -1, -7, and extending up to the right. This is a cubic graph. Remember that the graph of x cubed goes roughly like this through the origin. So we need to find hk to know where to shift this graph to. hk for this problem is 2, -4. So we're going to shift it 2 units to the right and down by 4. On the next screen, I'll walk you through that process. Okay, now we'll use GeoGebra to graph this equation. We'll begin with the basic graph of y equals x cubed. Goes through the origin, 1, 1, 2, 8, -1, -1, -2, -8. And we're going to shift this so that this point at the origin ends up at the point 2, -4. So let's go ahead and put that point onto the graph. Again, we want the same shape going through this point. Here's the way the graph will look. I've added on a couple other points that correspond to the point that was 1, 1 and -1, -1. And if we take the original graph off, there you have it. If an astronaut on the moon throws a rock upward with an initial velocity of 78 feet per second, the height of the rock in feet after t seconds is given by this function. We're asked to find the maximum height that the rock reaches. When we're looking for a maximum or minimum value of a quadratic function, we're looking for the vertex. The vertex will give us a maximum height here because this graph would be a parabola opening downward and it reaches its peak at the vertex. So we'll begin using the formula t equals -b over 2a to find how long it takes to reach its maximum height. Here that's going to be -78 over 2 times -2.6. That's -78 over -5.2. And that is equal to, let's see, 15 seconds. Now we have to plug that back into our function. So we're going to have -2.6 times 15 squared plus 78 times 15 plus 5. And this will give us our maximum height in seconds. And when we work this out with our calculator, we find that that height is 590 feet. Now, for some algebraic work with functions, here we're asked to find f plus g of x for these two functions. F plus g of x is the same as f of x plus g of x, which for us will be 4x plus 11, that's f of x, plus 3x minus 17. Simplifying by combining like terms, that will be 7x minus 6. To find f plus g of 8, we had two options. We could plug 8 into each original function and then add the results, or we can simply use the function we've created here. 7 times 8 minus 6, that's 56 minus 6, or 50. Real quickly, if we had plugged 8 into this function, f of 8 is 43, g of 8 is 7, 43 plus 7 is 50. Same idea with negative 3, 7 times negative 3 minus 6, that's negative 21 minus 6, or negative 27. On to the difference quotient. I'm going to take this in pieces. I'm going to begin with f of x plus h. That means I'm going to substitute x plus h into the function everywhere I see x. X plus h quantity squared. We multiply x plus h by itself. That's x squared plus xh plus xh plus h squared. I'm going to distribute the minus 9. It's going to be minus 9x minus 9h, and the 17 stays as is. I'll finish by combining these like terms. That's going to be x squared plus 2xh plus h squared minus 9x minus 9h plus 17. From that, I'm going to subtract f of x, and then I'll divide that all by h. So f of x plus h, again, is x squared plus 2xh plus h squared minus 9x minus 9h plus 17 minus the original function f of x was x squared minus 9x plus 17, and this all goes as the numerator over a denominator of h. Distribute that negative sign through. X squared plus 2xh plus h squared minus 9x minus 9h plus 17 minus x squared plus 9x minus 17 all over h. X squared and negative x squared cancel out. I've got a negative 9x and a positive 9x, a positive 17 and a negative 17, leaving only 2xh plus h squared minus 9h in the numerator, all over h. Basically, if you do this right, the only terms that survive the numerator should contain an h. To simplify this, I'm going to factor an h out of the numerator. That's going to be h times 2x plus h minus 9 all over h, and the h's divide out, leaving us with just 2x plus h minus 9. Moving on to some composition of function problems, I'm going to begin by finding f of g of x and then f of g of 3. We'll do the other two on the next slide. F of g of x is really notation for f of g of x. So for us, that's going to be f of, replace g of x by its formula, x minus 9. Now that we're going to plug in for each x in the function f of x. That's going to be x minus 9 squared minus 7 times x minus 9 minus 18. X minus 9 squared, x minus 9 times x minus 9 becomes x squared minus 18x plus 81. Distribute the negative 7, minus 7x plus 63 minus 18. Combine like terms. That's going to be x squared minus 18x and minus 7x is minus 25x. 81 plus 63 minus 18. Let's see, 81 plus 63 is 144. Minus 18 is plus 126. So to find f of g of 3, I just need to substitute 3 for x. 3 squared minus 25 times 3 plus 126. Moving left to right, that's 9 minus 75 plus 126. And using our calculator, we find that that equals 60. Okay, we're going to go ahead and work it in the other direction. G of f of x is g of f of x. And the formula for f of x, again, was x squared minus 7x minus 18. The formula for g of x, by the way, was just x minus 9. So I'm going to take the input and from that subtract 9. That simplifies pretty quickly to be x squared minus 7x minus 27. Now we were asked to find g of f of negative 4. So we're going to plug in negative 4 for x and simplify. Negative 4 squared is 16, minus 7 times negative 4, that's the same as plus 28, minus 27, and that all works out to be 17. Last problem for this part of the review, finding the inverse of a function. Remember that we put in y for f of x, and we interchange x and y. Again, this is a review, so I don't want to get too deep into this, but the reason we switch these two variables is that if the point xy is on the graph of a function, the point yx is on the graph of its inverse. We're going to multiply both sides by 3y to clear the fraction. So now I have 3xy equals 8 plus 4y. I'm trying to solve this equation for y. That means I need to get all the terms with y together. So I'll subtract the 4y over to the left side. I'm going to factor y from both of those terms. And I'm going to divide over the 3x minus 4. That gives me 8 over 3x minus 4. That is my inverse function. F inverse of x equals 8 over 3x minus 4. Okay, if you have any questions or comments on these or similar problems, if you'd like a copy of the review and an answer key to go with it, or if you have a request for a video you'd like me to put together, please go ahead and visit the contact page at my website. The address is georgewoodbury.com. Thanks and good luck.